Okay, so let's go ahead and get started. As a company, we're pretty focused on this industry study to be kicked off in February of next year. We're circling around and I think we have about 6 commitments right now, another 10 companies that are seeking budget approval. So this is shaping up to be a really promising and exciting study to embark upon with a group of collaborators. If you're interested, of course, just email me. So 2 weeks ago, we spoke about some of the peculiarities or intricacies of setting up wells in ResFrac. And today, we're going to talk about some tricks on setting up well sensitivities as it relates to well spacing. And that was a question that we addressed 2 weeks ago at a very high level, and I'm just going to dive into a few more of the details today, which will effectively constitute a lesson in geometry. So I hope you guys are ready for some high school mathematics. My mom was a math teacher at my high school, so I'm going to embrace my best impersonation of her. So last week, we covered Wellbore, importing wells in a variety of ways. So we discussed how you could put wells in using just a straight line. And this is very convenient if stresses are approximately parallel or perpendicular to the wellbore, and you can kind of just throw that into a straight line. Maybe you want to curve the heel a little bit, but for better or worse, you can pretty much approximate that with a straight line. We showed how you can just duplicate wells to quickly create multiple wells. And then probably the most typical import method at this point is using a well survey. And there's a wizard in the software where you can just paste the MD, azimuth, and orientation, or dip rather, and it will populate that full trajectory for you. And then we looked at how you can set up stages using the inline method, using the vertices, and converting back and forth and specifying using MD instead of XYZ coordinates. So today, we're going to extend that last topic of importing wells with a survey and look at the method of looking at different well spacing and how you can pretty quickly calculate positions of wells if doing a well spacing sensitivity. So if you just have straight lines representing your wells, doing a well spacing sensitivity is probably pretty trivial and straightforward to think about. So you would have a well, say, along the y-axis at a x position of 200, and then you could just put another one at 600, another one at 1,000, and you'd have 3 wells spaced 400 feet apart. If you have a well survey, you're likely not aligned with one of the axes. And so thinking about how to shift wells in these different coordinate systems becomes slightly more complicated. And so that's what we're going to draw out today and just show some simple geometry that allows you to do this. But first and foremost, can't emphasize enough, take out a napkin whenever you're doing this and just quickly draw it out, and you'll save yourself a lot of time and iteration versus trying to do it all in your head. So here's the fundamental process that we're going to address today. We have an axis system. Here I have my y-axis is to the north, x is to the east, and this dotted line is my well position. One thing to always keep in mind is what's our model domain, what are we modeling? And our convention is to set up the model such that our matrix region, as shown by this dotted blue box, is to be along the azimuth of SH max. And the reason we do that is that fractures then grow parallel and perpendicular to the meshing, which is efficient from a computational perspective, and also from using the imaging in the tool or visualization, it makes things much cleaner. So one way you could shift this dotted red well or create a new one is just to add a constant to all the y-axis values for the y vertices. And you would indeed shift the well into this new position, but that distance that you're shifting isn't necessarily the distance that is colloquially referred to as well spacing, because what we're interested in is what is the distance perpendicular to your well, which would be the second green line. And so that's generally the way that we think about well spacing, is not along various azimuths, but in fact just perpendicular to your original well orientation. So we can very easily calculate this new well bore position just using some simple geometry. So first thing we need to know is our well azimuth, which I've labeled as A. And presumably you have that from your well survey. And then secondly, your distance perpendicular is just going to be 90 degrees added to A. So I've called that B, which is kind of the azimuth of your spacing, or the angle perpendicular to your well bore. And then I've also labeled SH max as the angle H. And in this particular case, SH max and B are going to be the same. So these wells are optimally oriented such that they were drilled along azimuth of SH min. And so what we want to calculate is dx and dy, so that we know for any given point along this well bore where the corresponding point on the new well would be. And we can do so very easily. Again, B here is just SH max. So dy is going to be the sine of B times spacing. So this distance that you want to move the well. And equivalently, dx is going to be cosine of that angle times the same spacing. And so your new coordinates just become the original coordinate plus that cosine times the spacing. So that's your new x coordinate and your new y coordinate. And you can very easily shift that well. Next question is, what happens if your well is not perfectly aligned? So here, now my well is not drilled perfectly along SH min, but in fact, SH max is now at a slightly oblique angle to the well bore. So if we did our prior technique where we just looked at that well spacing distance and shifted, we would shift the coordinates directly perpendicular to the well bore. However, now if you look at my model domain, my original perforations are now shifted directly perpendicular to that well bore, but not within that original mesh that I defined, because I'm shifting perpendicular to my well bore rather than shifting along SH max. So we usually don't want to do that, but instead we want to shift along the azimuth of SH max such that all my wells are lined up and I don't have to change my meshing around my original well that I'm likely going to keep in my model if I'm doing a well spacing sensitivity. So it just a little extra trigonometry. We can still shift along and keep B as SH max, as we're going to shift that direction. But what we want to change is that distance that we're shifting, where this shift distance now becomes a function of your well spacing. So we can define that shift distance with respect to the spacing divided by a trigonometric function of your well orientation and SH max. And in doing so, you then get these new coordinates where you're multiplying by this shift instead of by spacing. So to save you all a lot of geometry, I do have a spreadsheet that does this for you. If you email me, I'm happy to send you this spreadsheet. And that's what I will use to just show a quick example. So if I exit full screen here, come over to my handy dandy spreadsheet. And in here, I use a convention in all my spreadsheets that If you've used any of my other little spreadsheet tools, you're probably already familiar with constants in gray, inputs in yellow, formulas in green, and then optional things in blue. So that's just a reference that I am using, but I don't use in any of the calculations. So the idea here is that you can paste in your reference well XY coordinates, and you can also put in an external fracture location. It will calculate that well azimuth for you, and then you can put in your SH max azimuth and what well spacing you want, and it'll generate 3 wells shifted by that well spacing. So I'm going to flip over to ResFrac, come into one of my simulations. So here, if I come into wells and perforations, you'll see I have 1 well defined. I can press the preview up top to see where that well is. So here's my single well. I just have a very simple geomodel with a pay zone where the well is landed in. And if I wanted to do a quick slice and then show my perforations, you can see that I have perforations kind of stretched out throughout the domain of that model. So what I want to do is I want to add another well adjacent to this at a set distance. And maybe I want to do 3 more wells to do a well spacing sensitivity. So what I'll do is I'll open up well number 1. I'll come in and I'll copy my X and Y coordinates. And then come back to my spreadsheet, paste in those coordinates, and you can see I have a well that is plotted. And my azimuth is calculated as about 35 degrees. Now, you'll note I have a little pink text here that says check formula is using the right straight portion of the wellbore. So if you open this up and click in the formula, scroll down, you'll see I just take 2 points along the wellbore and calculate the azimuth. Just make sure that those 2 points are somewhere along the straight section, as sometimes you have a curve in the heel or you're turning a corner if you're going from like a far reach pad. And if that's the case, you can just click and drag these formula boxes down to the portion that is then straight, such that you're getting the representative azimuth for your well. So you can see it changed a little bit when I went a little bit toward the toe. And then I define what SH max is. So if I come back to my simulation, I can come to static model. Scroll down and I have SH max as -20. So I'll put in -20. And then say if I want to try 300 meter spacing or 300 feet, then you can see it pops in a bunch of wells at 300 feet and they're all parallel to each other. And it tells you that that distance in SH max is 363 feet. Ignore the minus sign. It just depends on whether you define SH max as positive or negative. And that makes sense, right? So shifted along SH max, if this well is not perfectly perpendicular to SH max, will always be longer than the spacing in between the wells. And then I can also move my external fractures. So if I come to wells and perforations, I can copy the X, Y coordinates for my external fracture, pop those in here. And now you'll see this black line is my external fracture across all 4 wells. And just for demonstration, you can see that if I change SH max to something like 90 degrees, it'll change my orientations and spacings. You can see that now those external fractures will be at a 90-degree azimuth because they're aligned with SH max. So that's one visual cue you can use to make sure that you have things input correctly. So now that I have that, it's very easy to add these wells into my model. If I come back to the builder, I can click duplicate well. And I'm also going to use this convert perforation clusters. So right now it's set up inline. Instead, I'm going to specify by MD. Because I'm shifting those wells along SH max, the perforations are aligned with respect to measured depth. So I want to convert to the 1 at a time method and then specify by MD. And what's going to happen is right now those 2 wells are going to be on top of each other. So if I were to come in here and press refresh, you can't even see that there's 2 wells because they're directly on top of each other. And equivalently, if I come in here and look at perforations, those perforations are exactly stacked on top of each other. So you really can't tell that there's 2 wells there. But in my Excel sheet, I have calculated new coordinates. So I'll call that well 2. I'll come back to Excel and copy the coordinates for my shifted well. Looks like I may not have grabbed all my coordinates. So I want to drag my formulas down so that I have the same size region as what I originally pasted in. Back to well number 2. And paste those in. Now you can see my paste regions are the same. Again, MDs are going to be lined up. So I can keep my perforations as is if I have a similar perforating scheme. And then if we come back to this image, you'll see if I show external fractures, I have an external fracture set up on the toe side of that stage. And so when I replicate the next well, I'd like to have an external fracture as well. So I'll add a new row, come back to my spreadsheet, copy in my external fracture XY. And then I'm going to copy over the other values for demonstration purposes. Those might be subtly different if you're using activation time to allow leak off or simulate zipper fracturing. But for the time being, you can just keep those same values. And now if I come back to my preview and I click refresh, I have 2 wells that are spaced at the 300 feet. I can take a slice, show my perforations. You'll see that those are both aligned and centered within the matrix region. And if I show external fractures, you'll see that I now have them for each of my wells. So that was my quick demonstration of how to shift wells in a lesson in geometry. Any general questions or thoughts on Dave's hair? For those of you who haven't had the pleasure of seeing the mullet that's developing, I fortunately in the visual distance of Dave, where I can occasionally see that quaff flowing out from the back of his bike helmet.
Comment. I don't know what to say. I'm pretty sure I checked it actually at some point.
There's no defending it. That's why you can't say anything.
It's not a mullet. Just kidding, all over.
Well, maybe a short session then for today. Again, as always, we take suggestions if you have other issues that you are butting your head against or just curiosity, let us know. And we're more than happy to cover those in office hours.